Alright guys, we're back again with another Algebra 2A video. This time we're talking about absolute value. Absolute value of a number, written this way right here, as basically the absolute value of x, this guy right here with these vertical bars, means technically it's the distance from x to 0 on a number line. And here's the key, it will always be positive. Always be positive, because we always measure distance positively. So if we look at this box here, absolute value of x equals a, whether x is negative a or x is positive a. This means that absolute values actually have two solutions. They have the positive value of x and the negative value for x. And we'll get to the compound inequality stuff in a moment, but in order to solve an absolute value equation, here's what you've got to do. Isolate the absolute value. Step one is always isolate. Step two, we are going to separate. Separate. God, it would help if I could spell. You know, you guys don't know this, but I'm actually also certified to teach English, and I can't even frickin' spell separate. Separate, and then step three is solve. So it's a three-step process. Isolate, separate, solve. So first thing you got to ask yourself is the absolute value by itself? Is it isolated? And in this case, yes, it is. So my next step is going to be to separate it into two parts. I'm going to separate and assume that 2x plus 1 equals 7, or 2x plus 1 equals negative 7. So this part, the part on the other side of the equation from the absolute value, is what you change signs. You have a positive 7, you have a negative 7. Now the nice thing about these is, yes, it's two problems that you have to solve, but you are going to do the exact same thing both times. So I'm going to subtract 1 here, so 2x equals 6, divide by 2, and x equals 3. Here I'll subtract 1, and that would be 2x equals negative 8, so then x equals negative 4. So I have two answers. X equals 3 or negative 4. Two possibilities, two answers. Now one happens to be positive and one happens to be negative. It's not always going to be the case, but most of the time it'll be like that. So if we look at number 2 here, first step is to isolate that absolute value. This appears to be completely isolated. We don't have anything outside the absolute value bars. So then we're going to get negative 7x equals 28, or negative 7x equals negative 28. This one's pretty easy. Here x is going to be negative 4. We're going to divide. Here x is going to be positive 4. So you get these two answers, negative 4 or 4. And that's it. Here, wow, we got some stuff going on here. So we're going to have to isolate the absolute value. Miss Adams likes to say, clear the fences. So I'm going to add 7 to each side first. So I get 3 absolute value of 3x equals negative 5. Or no, sorry, add. It's going to be 9. And then I'm going to divide by 3. So the absolute value of 3x equals 3. The absolute value bars are basically impenetrable. All right, nothing gets in these absolute value bars. You cannot distribute. So I can't make this 6x or 9x. I got to get rid of that 3. So I got to divide it. So once this is isolated, we are going to then separate. So I'm going to get 3x equals 3. So that means x equals 1. Or I'll have 3x equals negative 3, which means x equals negative 1. And again, I have 1, 2 answers. I could do some more of these, but these all basically work the same way. I hope you get the idea of what's going on. Now, here's the deal. With compound inequalities, remember we had basically two inequalities joined together with either and or with or. Absolute value inequalities are always going to be compound inequalities. And there's two types: less than, greater. And here's what I tell my kids. So you think about it. If it's less than, think this. Think less than. So you see less than, whether it's less than or equal to, it's going to be an and. And if it's greater, think greater, right? So greater, it's greater than, you're going to have an or situation. And here's some examples here. These are in the reteach. This is basically a copy of the reteach, so I'm not going to go back and show you those, but we have absolute value of x minus 2 is less than or equal to 3. So that's an and situation. It's less than, so it is and. So what they did is they wrote it this way. All right, so x minus 2 is less than 3, or x minus 2 is greater than or equal to negative 3. Remember that when you change this inequality to make the value negative, you've got to reverse your inequality. And it'll be more obvious with the or in a minute. But so basically I'm going to add 2, and I get this, negative 1 less than or equal to x, less than or equal to 5. Graph it. There it is. So if we look at the or one, we've got the absolute value of 2x minus 1 is greater than 5. It's definitely an or. So I'll have the greater than 5 over here. Right? Just get rid of those absolute value bars. And it's very similar to what we did up here. We just got rid of the absolute value bars, and we got x plus 1 equals 7. But then when we make it negative 5, which is what we have to do, we have to then flip the inequality, because we're basically changing that sign to a negative, which means we're kind of like multiplying by a negative, so we have to flip it. So greater than becomes less than. And this is why these are ors, because they're going to end up pointing in opposite directions. I'm going to solve them the same way. They're adding 1, so they get 2x equals 6 right here, and then so x is less than 3. Here they add 1, they get 2x is less than negative 4, they get x is less than negative 2. So x greater than 3, I may have said less than earlier, it's definitely greater than. You got that open circle in the line pointing to the right. Less than negative 2, you got that open circle in the line points to the left. So greater, less than. And that will always be the case. So let's take a look at this one. This is less than. So I'll have the positive 2 over here. I'll have a negative 2 over here. And I'm going to work it out. All I'm going to do, if I'm adding 3, is I'm going to subtract 3. And if I subtract 3 on this side, I got to do the same thing over here. So this is actually a pretty simple way to do it. Just put your expression in the middle. You'll have negative 5 is less than x, which is less than negative 1. So I'll have an open circle at negative 5 and an open circle at negative 1. And I'm going to be going in between them. Number 8 here, we have the absolute value of 2x plus 1 is greater than or equal to 3. So I'll have greater than or equal to 3, and I'll have less than or equal to negative 3. I'm going to solve each of these the same way. So I'll subtract 1. So I get 2x is, oops, did a little mistake there. 2x is greater than or equal to 2, so x is greater than or equal to 1. And then over here, if I subtract 1, I got 2x. Why am I doing this? 2x less than or equal to negative 4, so x is less than or equal to negative 2. And again, these are or. So let's see. Close circle at 1, close circle at negative 2. I got my arrows pointing in opposite directions because that's the way this goes. Or. All right. Let's do 2 more. 0.3x greater than 1. All right, so that means that 0.3x is greater than 1, or 0.3x is less than negative 1. I'm going to divide by 0.3. Divide by 0.3. It's going to actually be bigger. 1 divided by 0.3 is, well, I forgot my variables. I'm falling apart, people. So x is going to be greater than 3.3 repeating, which means that x is greater than 3 1/3. Same thing over here. X is going to be less than negative 3.3 repeating. So x is less than negative 3 1/3. So let's see. On the calculator, 3 1/3, maybe right there, and then right there. And we'll have our arrows pointing in opposite directions because it's or. Number 7, got to clear the fences just like you do with absolute value equations. So I got to add 12. So I get negative 7x. Absolute value of negative 7x is less than or equal to 21. So this is less than, so I'll have 7x less than or equal to 21, greater than or equal to negative 21. I'm going to divide everything by 7. So I got negative 3 less than or equal to x less than or equal to 3. A little bit easier to graph, like so. Boom. All right. Story problems that involve absolute value are basically range type of problems. You will see some of these in your homework. Here's what you're going to have to do to set it up. So let's take a look at this. The measurement is accurate within plus or minus 0.5 of the measurement unit. For example, if you measure your pencil to the nearest inch, you could be off by a quarter inch either way, or a half inch. 0.5 inch too long, or maybe a 0.5 inch too short. Write an absolute value inequality that shows the maximum and minimum actual measure for a nail that measures to be 4.4 centimeters to the nearest 0.1 centimeter. So the way we set these up is you're going to have your absolute value of your target value. Your target's going to be here. If I measure my pencil to be 4.4, my absolute value has to be less than or equal to x minus the variability. Hold on a minute. Let's pause. I gotta double check this one because I want to make sure. All right, I'm back. Yeah, I went back and double checked, and I'm wrong. So here's the deal. Here's what you're going to do. Whenever I'm setting these up, I've got this. This is my measurement, and then this is my variability. So the variability is going to go here. I'll show you. It's going to be x minus my measurement has to be less than or equal to my variability. So I could be 0.1 either direction. So when I'm going to solve this, this is a less than situation. So we would have negative 0.1 less than or equal to x minus 4.4, which is less than or equal to positive 0.1. And I'm going to add that 0.44 to each side. And I'll get, let's see, that would be 4.3 on the low end and 4.5 on the high end. So that would be my range. So if I measure my pencil to be, or a nail, I think they said it was a nail, to be 4.4 centimeters, because I have inherent inaccuracies in just measurement, it could actually be 4.5, it could actually be 4.3. That's my answer. So whenever you're doing these kinds of story problems, and you might see some in your homework, look for the target and look for the variability. So it's going to be x minus the target absolute value has to be less than or equal to the variability. That means your plus or minus value. So they might say plus or minus 100. They might see plus or minus 0.5. And you'll see it. See how this says plus or minus? Now that 0.5 doesn't really work for this problem because we've got to read the actual problem, and they mean to the nearest 0.1, but you know, that's basically what it is. So you're going to set them all up that way. If you have questions, make sure you message me. If you learned something today, make sure you press that like button and subscribe. I'm up to 9 subscribers. Can we at least get to double digits? Come on, people. All right, talk to you soon.